Mikrofon, alat mengeras suara yang tidak asing dan digunakan oleh hampir seluruh kalangan, terutama para musisi. Mikrofon dipakai pada hampir semua alat elektronik seperti handphone, alat perekam, alat bantu dengar, dan pengudaran radio dan televisi. Namun, apakah kamu tahu mikrofon bekerja dengan prinsip fisika? Ada banyak tipe dari mikrofon dengan bentuk dan kualitas berbeda-beda. Tetapi semua mikrofon ini bekerja dengan prinsip yang sama, yaitu transducer. Transducer adalah suatu alat yang dapat mengubah suatu bentuk energi ke bentuk energi lainnya. Dalam kasus ini, mikrofon mengubah energi akustik atau gelombang suara menjadi energi listrik dalam bentuk sinyal audio. Semua tipe mikrofon memiliki diafragma di dalamnya. Diafragma adalah sebuah material tipis berupa kertas, plastik, atau aluminium. Saat kita berbicara, suara kita akan membentuk gelombang suara dan menuju mikrofon. Dalam mikrofon, gelombang suara akan menabrak diafragma. Diafragma akan bergetar sesuai gelombang suara yang diterimanya. Terdapat pula sebuah koil atau kumparan kawat yang terdapat di bagian belakang diafragma yang akan ikut bergetar sesuai dengan getaran diafragma, dan sebuah magnet yang dikelilingi oleh koil atau kumparan ini. Pada bagian inilah konsep fisika bekerja, konsep GGL induksi yang dikemukakan oleh Michael Faraday. Jika sebuah medan magnet didekatkan ke kumparan, maka arus listrik akan dihasilkan pada kumparan tersebut. Adanya medan magnet seiring dengan getaran koil ini akhirnya menimbulkan arus listrik. Arus listrik yang dihasilkan ini berupa sinyal audio. Sinyal audio yang dihasilkan mikrofon sangat lemah. Bagaimana mengubah sinyal yang lemah ini menjadi lebih kuat? Sinyal audio ini diteruskan ke amplifier. Di dalam amplifier, dengan bantuan prinsip step up dan step down, sinyal audio yang lemah ini dapat diperbesar sesuai keinginan.
The operating principle describes the type of transducer that the microphone uses to convert sound into an electrical signal. The most common transducer types are dynamic and condenser. In a dynamic microphone, sound waves strike a thin plastic diaphragm and cause it to vibrate. A coil of wire attached to the back of the diaphragm vibrates along with it. As the coil moves back and forth, it passes through a magnetic field created by a magnet, which generates an electrical signal that corresponds to the sound. Dynamic microphones can handle even the loudest sounds without overloading, but this also means that they're not well suited to distant miking of quiet sources. Because the sound waves have to move the mass of the diaphragm and the voice coil, they usually have limited high-frequency detail, so they're better for vocals or horns than for stringed instruments. The size of the magnet makes it difficult to make a dynamic mic very small, which can limit your mounting options. In a condenser microphone, sound waves also strike a diaphragm and cause it to vibrate. The diaphragm is mounted just in front of an electrically charged plate. As the diaphragm moves back and forth, it changes the electric field between the diaphragm and plate, which generates an electrical signal that corresponds to the sound. Since there is no voice coil in a condenser mic, the sound waves only have to move the diaphragm. This gives condenser mics better high-frequency detail than dynamics. This makes them ideal for miking stringed instruments, percussion, piano, or subtle vocals. Condenser mics usually have higher output than dynamics, so they're good for distant or quiet sources. Since there's no magnet in a condenser mic, they can be made extremely small, which makes it easier to mount them in tight spots and make the mic less visible. Condenser microphones have internal circuitry that requires power to operate. Usually, phantom power is supplied through the microphone cable from the mixer or recorder. Some condenser microphones can run on an internal battery, but that's less common. Unlike dynamic mics, the electronics in a condenser mic can overload when exposed to very loud sounds. Make sure that the condenser mic you're using can handle the sound levels that the source can be expected to produce. By understanding microphone characteristics like operating principle, you'll be able to choose the best mic for any application and get better results when recording or using a sound system. The sound of a microphone is illustrated by its frequency response curve. The frequency response defines the range of sound that the mic can reproduce and how sensitive it is within that range. A microphone with flat response is equally sensitive to all frequencies, so it reproduces voices and instruments with little or no coloration or variation from the original sound. Flat response mics are a good choice for miking acoustic instruments, vocal groups, and orchestras. A microphone with shaped response is more sensitive to some frequency ranges than others. A mic with increased sensitivity in the upper mid-range adds clarity to vocals and also works well on instruments like guitar amplifiers or drums. A mic with decreased sensitivity to low frequencies reduces pickup of room noise and vibration and counteracts the buildup of bass that can occur when the mic is used very close to the source, which is called proximity effect. The choice of frequency response for miking a particular voice or instrument is very subjective. In general, however, microphones with shaped response work better than flat response mics for vocals. Here's how a vocal sounds on a Shure SM81, which has a very flat frequency response.
For I'll be here in sunshine or in shadow. Oh, Danny boy, I love you so.
Here's the same vocal recorded with a Shure KSM42, which has a shaped response.
For I'll be here in sunshine or in shadow. Oh, Danny boy, I love you so.
Some microphones allow the frequency response to be adjusted to match different sound sources or recording conditions. The most common is a low-frequency roll-off control. In the flat position, the mic picks up low frequencies normally. In the roll-off position, the mic's sensitivity to low-frequency sound is reduced. By understanding microphone characteristics like frequency response, you'll be able to choose the best mic for any application and get better results when recording or using a sound system. A microphone's polar pattern defines how it responds to sounds coming from different directions. The polar pattern tells you how the mic should be placed to maximize pickup of the desired sound source while minimizing feedback or pickup of background noise. An omnidirectional microphone has the same output regardless of its orientation to the sound source. Its polar pattern is a sphere. On paper, it looks like a nearly smooth circle. In this demonstration, notice how the sound level remains virtually constant even as the angle between the microphone and the sound source changes. An omnidirectional mic can pick up a group of people sitting around a table, but it can't be aimed to favor one source over another. A unidirectional microphone is most sensitive to sound coming from one direction. A unidirectional mic picks up less ambient noise than an omnidirectional type and is less susceptible to feedback when used with a sound system. The most common unidirectional pattern is the cardioid, which is so named because it resembles a heart. A cardioid microphone is most sensitive to sound sources in front of the mic and least sensitive to sound sources that are directly behind the mic. A cardioid mic has a useful pickup angle of approximately 130 degrees, which can accommodate two talkers or singers, or one user who may not always be directly in front of the mic. In this demonstration, notice how the sound level gradually drops as the angle between the microphone and the sound source changes. A supercardioid microphone has a narrower pickup angle than the cardioid, but unlike the cardioid, it is slightly sensitive to sound sources that are directly behind the mic. A supercardioid mic provides better isolation from room noise and nearby instruments and can be more resistant to feedback than a cardioid, but it requires the user to maintain a more consistent position directly in front of the mic. In this demonstration, notice how the sound level drops more rapidly as the angle between the microphone and the sound source changes. The microphone's polar pattern affects where floor monitors should be placed to minimize feedback. With a cardioid mic like the SM58, the floor monitor should be placed directly in front of the mic stand. This way, it is aimed at the least sensitive part of the microphone's polar pattern. If the same monitor speaker placement is used with a supercardioid microphone, it will be facing the sensitive area at the back of the supercardioid pattern. Feedback will probably be worse than with a cardioid mic. With a supercardioid mic like the Beta 58, floor monitors should be placed slightly to the sides of the mic stand. This way, they're aimed at the least sensitive part of the microphone's polar pattern. This arrangement allows a supercardioid mic to deliver more gain before feedback than a cardioid. A bidirectional microphone is equally sensitive to sounds coming from the front and the rear of the mic, and least sensitive to sounds coming from the sides. Bidirectional mics have a very narrow pickup angle. This makes a bidirectional mic useful for isolating one voice or instrument that is surrounded by other sound sources, as long as there is nothing directly behind the mic. In this demonstration, notice how the sound level drops off dramatically when the sound is coming from the side, but returns when the sound is coming from the rear. The microphone's polar pattern affects not only how it picks up the sound source, but also how it behaves in a particular room or with a particular sound system. By understanding microphone characteristics like polar pattern, you'll be able to choose the best mic for any application and get better results when recording or using a sound system. When choosing a microphone, you need to consider the sound source and the equipment that the microphone will connect to. In other words, the mic needs to be compatible with both the acoustic characteristics of what you're miking and the electrical characteristics of the sound system or recorder that you're using. If it isn't, you might have problems with noise, low level, or no audio at all. The specifications that relate to connectivity are collectively known as the microphone's electrical output. The sensitivity or output level of a microphone is defined as the voltage of its output signal when it is exposed to a certain sound level. A more sensitive mic puts out a higher voltage than a less sensitive mic, assuming that the incoming sound level is the same. A more sensitive mic can pick up quieter or more distant sound sources, while a less sensitive mic usually works better for loud or close sound sources. If you try to use a less sensitive microphone on a quiet source, you'll need to turn up the level on your mixer or audio interface to compensate. Depending on how quiet your equipment is, this may create hiss. Listen to the difference as we record a person speaking as they might when recording a podcast. Here's the more sensitive mic. He wrote down a long list of items. Now here's the less sensitive mic. A siege will crack the strong defense. The sensitivity of a microphone can be specified as a voltage or in decibels above or below 1 volt. Because microphone signals are typically less than 1 volt, the decibel figure is a negative number. A higher number means the microphone is more sensitive, while a lower number means the mic is less sensitive. The sensitivity specification is meaningless unless you know what sound pressure level, or SPL, the mic was exposed to when it was measured. Most microphones are tested at a sound pressure level of 94 decibels, also known as 1 Pascal. You might see either notation, but they mean the same thing. The impedance of the microphone is important because it affects how it interfaces with the next device in the audio chain and its ability to be used with long cables. A low impedance mic, with an impedance of less than 600 ohms, can be used with cable lengths of 1,000 feet or more with no loss of sound quality. For this reason, professional microphones always have low impedance. A high impedance mic, with an impedance of more than about 10,000 ohms, should not be used with microphone cables longer than 20 feet. With longer cables, the sound can become dull or muffled. A microphone's wiring configuration affects the signal's tendency to pick up electrical noise or hum as it passes through the cable. A microphone can be configured with either a balanced or an unbalanced output. A microphone is said to have a balanced output when the signal is carried on two conductors with a separate connection to the metallic shield inside the mic cable. The signal on each conductor is the same level but opposite polarity. When connected to a balanced input on a sound system or recorder, this configuration is very effective at rejecting electrical noise and hum and is essential for longer cable runs. An unbalanced microphone output carries its signal on just one conductor with a separate connection to the metallic shield inside the mic cable. An unbalanced connection is not very effective at resisting electrical noise and hum, so unbalanced microphones are typically used only with shorter cable runs. However, most modern professional microphones have balanced outputs, so as long as you're connecting to a device with balanced inputs, this is not an issue. The most common connector used for balanced configurations is the XLR type. A 3-pin male version is used for outputs, while a 3-socket female version is used for inputs. There are some specifications that only apply to condenser microphones because they relate to the electrical circuitry that is part of a condenser mic. The circuitry inside a condenser microphone generates a small amount of hiss, which is called self-noise. It's specified in decibels, and the lower the number, the quieter the mic is. Low self-noise is especially important if you're recording quiet voices or instruments, or the mic will be located relatively far from the source. The maximum SPL is the loudest sound that a condenser mic can handle without overloading the internal electronics and causing distortion. This is important if you will be positioning the mic close to a loud source, such as a guitar amp or drum. Some condenser mics include a switchable attenuator or pad that reduces its sensitivity. This extends the microphone's ability to handle very loud sounds without distortion. Most pads allow the mic to tolerate sounds that are 10 to 20 dB louder. The difference between the maximum SPL and the self-noise is called the dynamic range of the mic. This is essentially the range of sound levels that the microphone can work with. A wider dynamic range lets you use the mic in a wider variety of conditions. Most condenser microphones are powered by phantom power from the mixer or recorder. The required voltage and current consumption will tell you if the microphone will work with the inputs on your mixer or recorder. Phantom power is a DC voltage, usually between 12 and 48 volts. Some condenser microphones can operate on a wide range of phantom voltages, while others require exactly 48 volts. Make sure that your mixer or recorder can supply the voltage that your condenser mic needs. The microphone's electrical output gives you a better understanding of its capabilities and how it will work with your equipment. By understanding microphone characteristics like electrical output, you'll be able to choose the best mic for any application and get better results when recording or using a sound system.